Walking with Dinosaurs was a groundbreaking documentary series that explored the tumultuous saga of the dinosaurs' evolutionary history, from their origins to their bitter end. While many aspects of this show are outdated, which I talk a bit more about in my redesign series, which you should totally watch, it's undoubtable that over 25 years later, it holds up for its vision and merit, with Apple TV's Prehistoric Planet being the only real competitor. Walking with Dinosaurs had a bit more of a novel approach, with episodes being more localized to a single place, hosting a cast of creatures which we followed throughout various portions of their lives, in well-told narratives that were interwoven with each other. While many documentaries attempted this and often personified their dinosaurs to somewhat of an extreme extent,
and stay away!
The show kept its plots relatively grounded. The downside, however, is that due to the budget and scope, many creatures were unfortunately left on the chopping block. So we'll be taking a look at some critters that were just off-screen during the show, starting naturally with the first episode, New Blood. New Blood takes place in Arizona towards the end of the Triassic period. The locality represented is the Chinle Formation, a large rock layer that covers a chunk of the southwestern United States and is home to almost all of the animals featured here. The environment was surprisingly cool and lush, with river deltas and lakes being quite common occurrences, crisscrossing the landscape. The dry season came around as well, and while dry and hot, wasn't close to the extent that we see in the episode.
It is a harsh place, dominated by deserts.
With the intent of documenting the history of Dinosauria, it only made sense to begin at their origins. To capture this message, we see Coelophysis bauri, a small theropod whose success as a species must truly be commended. Hundreds of specimens are known, and with its appearance in Walking with Dinosaurs, it's become a bit of a household name among paleo enthusiasts. Throughout the duration of the episode, we see a single individual, using her resourcefulness to survive in a harsh world. Yet with the passage of time, more appear, swelling in population until all that remains by the end is a cacophony of dinosaurs.
The Triassic is pushing life to its limits,
only subsiding with the triumphant arrival of the Plateosaurus. But this narrative is far from watertight. Setting aside the flawed argument of evolutionary obsolescence, which is an entire discussion in itself, the episode's sole highlighting of Coelophysis, while sound from a budgetary standpoint, and would sort of make sense because of its large numbers, leaves out a wider picture. North America is actually fairly unique when concerning Triassic dinosaur material. While the enigmatic Herrerasaurians, early Ornithischians, and Basosauropodomorphs made their lives throughout the world, this diversity isn't present in North American rock. Sauropodomorpha and Ornithischia are considered absent entirely due to a lack of diagnostic material, and with only a handful of exceptions, all dinosaurs found in the Norian of Triassic North America are of Neotheropod affinity. But I'm going to discuss a much stranger and little-known dinosaur. This is the skull of Daemonosaurus cheliotis,
a prominent-toothed demon lizard.
This crushed cranial material is the majority of the animal currently known, accompanied by a smattering of anterior cervical vertebrae. It was unearthed in the Coelophysis quarry at Ghost Ranch, meaning it was a contemporary of Coelophysis and would have been present in the episode. The skull was narrow and lightly built, which isn't unusual for theropods of this age, with large orbits as well. Interestingly, the sclerotic rings, which would have supported the eye and life, only had 11 scleral plates, unlike the roughly 20 of Coelophysis. I'm unsure what this implies for its eyesight, however. But unlike its peers, the skull was proportionately deep, but easily the most eye-catching and bizarre part of the skull is the dentition. Huge premaxillary teeth jutted forward and surpassed the bottom of the jaw, giving it an extreme overbite. The maxilla had similar teeth at the front, but more traditionally oriented. The back of the maxilla and the dentary had smaller teeth, making Daemonosaurus one of the few dinosaurs that exhibit heterodont dentition, but besides the size, the shape and texture of the teeth were also varied. Towards the front of the premaxilla and dentary, the teeth were rounded, and the front of the first two dentary teeth were equipped with a slicing edge, which apparently is called procumbency and is seen in some rodents. The maxillary and posterior dentary teeth are more traditionally flat and finely serrated, like you'd see in a lot of theropods. What exactly Daemonosaurus was is still up for discussion. The original 2011 description finds it to be most closely related to another Chinle dinosaur, Tawa, and we'll come back to Tawa in a little bit. Besides that, it was found to be outside of Neotheropoda, but more derived than the Gondwanan Herrerasaurids and Eoraptor. The paper really pushes the idea that Daemonosaurus and Tala were these bridging animals that connected the neotheropods to the animals of Ischigualasto and their relatives, with the abstract stating, "The skeletal structure of Daemonosaurus and the recently discovered Tala bridge a morphological gap between Eoraptor and Herrerasauridae on one hand, and Neotheropoda on the other." This devolves fairly quickly as the phylogenetic relationships between early divergent dinosaurs was reanalyzed. Luckily, a 2022 paper revisited Daemonosaurus and gave a complete osteology and classification to account for the tumultuous world of early dinosaurs. While it's definite that Daemonosaurus was a dinosaur, its fate is apparently tied to that of Herrerasaurus, alongside Tawa, Chindisaurus, and Eodromeus. Considering the absolute clusterfuck that is Herrerasaurus' phylogenetic position, this is far from reassuring.
Who are you?
I've been asking the same question.
The problem originates from the fact that these genera have an odd mixture of Herrerasaurian and theropod-line traits that cause problems due to their seeming hodgepodge of characteristics. And of course, this is ignoring the whole Ornithoscelida debacle. What further exacerbates this point is the lack of postcranial material, leading to an infuriating lack of definitive character stats. So for now, all that is somewhat stable is that Daemonosaurus was an early Saurischian outside of Neotheropoda, more derived than Herrerasaurus, possibly diverging before the theropods split with the sauropods, and being closest phylogenetically to Tala. Returning back to the individual specimen, it's unclear how mature it was when it died. Because we only have a single animal and no accompanying similar animals with any semblance of a robust growth series, it's difficult to determine. That and the complicated ontogeny of early dinosaurs in general leaves us in the dark. The skull was measured at 140 millimeters from the top of the snout to the back of the quadrate, with the antorbital region being only half of the skull's length, which is quite bizarre. The full animal was estimated by Thomas Holtz to be around 7.2 feet, with a, quote, beaver-sized mass, in an appendix to his book, The Most Complete Up-to-Date Encyclopedia for Dinosaur Lovers of All Ages, a book which I own, and I really love that book. One of the co-authors for the original description estimated that Daemonosaurus was closer to 5 feet and as tall as a large dog. So these sizes are conjectural, with the ontogeny being unknown and the body being completely missing. Maybe just take this with a grain of salt until we get further information. The length of the cervical vertebrae that we do have, their corresponding cervical ribs, which were long and spindly, and the fact that they were parallel to the centra, suggest a long neck, similar to that of Tawa. And since Tawa is the closest known relative of Daemonosaurus, we can use it to fill in some gaps. A long neck and slender build seems appropriate, with 4-fingered hands, 3 of which were clawed, a long tail, and slender but strong limbs. Now, integument is something to be pondered. Usually tuberculate scales would be the safer option, but for Daemonosaurus, feathers might make more sense. A study in 2020 modeled 2 Triassic animals, Coelophysis and Plateosaurus, and subjected them to various conditions within their native paleo environment. Among the results of the simulations was the remarkable find that a featherless Coelophysis was almost impossible with the amount of cold stress it would have received throughout the year.
Now, the Chinle Formation wasn't this cold, but it was not exactly warm.
Hi.
A fully feathered animal was deemed the most plausible, and this would apply to Daemonosaurus as well, especially given that it was smaller. A difficult thing to fathom might be lips. With Cullen-et-al.'s 2023 paper, lips have become standard for dinosaurs, and the telltale signs for lippage, including the nutrient foramina, would indicate this to be the case, but with how wild its dentition is, how is this possible? I look to the convergently bizarre orthodontics needing no saurid Mosasaurus. Mosasaurus was portrayed quite naturalistically in Prehistoric Planet, while being demolished of course, but it had realistic lips that fit the mouth well. The paper describing Daemonosaurus doesn't say that the tooth length is from slippage, and I myself don't know exactly how to tell just from figures, but from what I can see this may very well be the case. Regardless, adequate soft tissue and a properly articulated jaw can make this toothy freak look a little bit more familiar. While Coelophysis had competition to consider, the apex predator of the area had bigger hazards to worry about. In New Blood, we're introduced to the apex land predator, Postosuchus kirkpatricki. Postosuchus belonged to the larger clade of Pseudotsuchia, the clade which contains crocodilians and their relatives. Back during this time, crocs were land predators, and in this case, bipedal ones capable of running down prey. They weren't lumbering animals that were outmatched evolutionarily by the dinosaurs, as the show suggests. Truly a terrifying sight, and at 5 meters long, Postosuchus had the pick of the litter when it came to prey. Yet it wasn't the biggest predator in this area.
A merciless ambush predator, the largest carnivore on Earth.
Liar!
And just because crocodiles weren't patrolling the waterways, doesn't mean that they were safe by any means. A different group of reptiles lurked in these shores. Phytosaurs are clade of archosauriforms. They are probably the closest the natural world got to creating crocs without creating crocs. The crocodilian niche and body plan preceded them for millions of years, and whether it be phytosaurs, temnospondyls, or charistoderans, nature just really loves this animal type. Phytosaurs are known from the late Triassic, but their ghost lineage apparently extends to the early Triassic. They have a superficially similar appearance to crocs, with a pelvic girdle hinting at a sprawling posture, 2 rows of paramedially oriented osteoderms, as well as more random ones around the body. And of course, their skull shape and lifestyle. Unlike crocs, however, Phytosaurs had a gular shield of throat armor, made of a complex network of osteoderms. This reminds me a bit of what's seen in Stegosaurus, but I didn't see any figures of this structure though, so that kinda sucks, but it's a cool tidbit, no? The nares were much more posteriorly placed than those of crocodiliforms, and bring to mind older reconstructions of sauropods, unlike those of crocs, which are at the tips of their rostrum. Quite fascinating creatures for sure. In the Chinle Formation lived a contender for the largest of this group, Smilosuchus. Smilosuchus means chisel crocodile, and there are 2 species known here, Smilosuchus gregorii and Smilosuchus adamanensis. Gregorii is the larger of the 2, and has estimates ranging from 7 to 12 meters in length. This makes it at the upper end, almost similar to the heavy-hitting Suki and Sarcosuchus purosaurus and Dinosuchus, which is just insane to me. The 2 species were quite noticeably set apart by their skull shapes, with Adamanensis being closer in appearance to forms like Rutiodon, and Gregorii being more boxy and convex. Smilosuchus' jaws were large and robust, with blade-like teeth for slicing through flesh, unlike the conical teeth of crocs. For phytosaurs, I'll depict them without extra oral tissue since they're so similar to crocodilians that a convergent evolutionary pathway away from the lipped condition feels reasonable. They were heterodont, like Daemonosaurus, and had larger tusks towards the front of their jaws. The tips of the jaws themselves had pronounced bulges, superficially similar to those of the modern gharial, and may have been used for social signaling just like the modern gharial. Other potential display structures include the crests and emphasized nasal areas of the skull. Dinosaur fossils are particularly common in Germany and the southwestern United States, their teeth making up a large amount of fossil material found in these areas. But postcranial material is far less well understood across the entire clade. In fact, Smilosuchus is one of the few with studied material such as this, and yet even then it's not the most complete. It's so poorly understood that most paleobiological assessments on phytosaurs are based on their convergence with crocodilians and not actual material, while a much greater attention is placed on their scullodiversity, which is mighty impressive. I'll be basing my reconstruction on USNM 18313, which actually has some nice figures and postcranial material, those being mostly limb elements, parts of the vertebral column, and some other bits. A 2021 paper measures this animal's skull at over a meter in length and gives a full-length estimate of 5 to 6 meters. This poor guy was covered in bony lesions and growth indicative of a very unhealthy condition that the authors suggest was survived for around 2 to 3 weeks before death. In the reconstruction, I buffed up the length closer to 9 meters, and that's why the Postosuchus looks so small in comparison. In fact, it might have been a little bit too big, but it's still lower than the highest estimations. With its large size, pretty much all in the ecosystem were fair game. Even when I first watched the documentary when I was younger, I wondered why the Placerius weren't worried at all about being at the water's edge. Shout out to When Dinosaurs Roamed America for including Rutiodon, because I don't think I've seen any other phytosaurs in a documentary since. This is feeling quite a bit carnivore-centric. Let's switch gears a bit. Most creatures in New Blood are carnivorous in some capacity with only 2 exceptions, them being Placerius and Plateosaurus. I talked more about Plateosaurus in my redesign video, but I neglected Placerius completely. Unlike Plateosaurus, we actually know Placerius from the Chinle Formation, and in fact, they're decently common fossils. Being large dicynodonts, Placerius were synapsids, the clade of animals including gorgonopsids, dinocephalians, and modern mammals. Placerius, as it's seen in the episode, are social animals that dominate the herbivore niche in the ecosystem, but they're depicted as these backwards relics, with Kenneth stating,
But these ancient creatures have had their day.
They pretty much disappear by the time the very out-of-place sauropodomorphs show up. But there were quite a few other animals munching up the foliage. Now you've heard of Monolophosaurus. You've heard of Dilophosaurus.
Yeah, bitch!
Now get ready for Trilophosaurus. Trilophosaurus belonged to Allocatusauria, their closest relatives being the Azendosaurids, which are most well known for the Indian Shringosaurus. These reptiles had very lizard-like bodies, with them evoking an image similar to modern varanids, but with a much more robust head, having lost their lower temporal opening. With the type specimen T. buitoneri being named in 1928, we've known about this genus for almost 100 years, and we have plenty of skeletal material to paint a very good picture of this animal's appearance, with the Trilophosaurus quarries being named for how they're the predominant fossils known from those rocks. The type specimen is an almost complete skeleton, with some bits missing from the tip of the head, tail, and limbs. Like you might have guessed, Trilophosaurus means three-crested lizard, but these three crests aren't as showy as those of its peers. They are based on its teeth being tricuspid in nature. These teeth were well equipped for crushing plant material, and their absence in the premaxilla implies the presence of a beak. The skull was short and deep with the parietal crest developed. The neck was quite short compared to other archosauromorphs, and the limbs were rather long with large hands and feet, each with 5 fingers and toes. Paleoecological studies have found Trilophosaurus to potentially have been herd animals thanks to their large numbers and the separation of size classes between different Trilophosaurus quarries. The aggregations of these groups also varied in origin, some being interpreted as catastrophic flash floods, while others being more gradual deposits, thought due to the presence of insect burrows which would be obliterated by a flood. Honestly, it would have been really cool to see herds of Trilophosaurus alongside the Placerius or even competing. While this may bring images of the old Slurposaurs to the surface, there is a quirk of Trilophosaurus I've yet to mention: its affinity for trees. Heckert et al. In 2005 looked for an explanation as to why Trilophosaurus was both rare to find, but also extremely common in places they were found, suggesting a different habitat type to typical fossils in Chinle. They found arboreality to be the most plausible lifestyle for this critter after looking at the functional morphology of its limbs, digits, and comparing them to other animals, including the probably arboreal Daemonosaurus. They found the body proportions, morphology of the pectoral girdle, and limbs, among other features, to suggest a tree-dwelling lifestyle. This really lends credence to their superficial resemblance to elongated iguanas, basically, and the trees in New Blood were completely neglected, which is interesting because the Chinle Formation includes Petrified Forest National Park.
That's always been Wiley's problem. He can't see the forest for the trees.
I imagine Trilophosaurus to be a somewhat colorful animal. Even though they aren't related to lizards in any meaningful way, their lifestyles and biology are incredibly similar, so I feel they're the best source of inspiration for coloration, and there is no shortage of immaculately pigmented herbivorous saurians wandering the earth and munching through foliage. And with iguanas being such good analogs, it just makes sense. And there we have it, some oddball life forms that were just out of reach during the supposed filming of New Blood. Of course, there were plenty more animals I could have used. I actually really wanted to include Trypanosaurus, Vencliava, or maybe even Chindesaurus, but drawing 6 animals was already a lot, and I didn't want this to be a list of Wikipedia's paleobiota of the Chinle Formation. But there's a ton of potential in this style of video, so let me know what you think in the comments. Remember to smash that like bell and notification button to unsubscribe.